Okay, for this video, we'll be doing a DC circuit part 2. Okay, so I'll start from question 6 onwards. Okay, so the question says that the following shows a circuit containing a 12-volt power supply, which is here, some resistors and an ammeter whose resistance is so small that it may be ignored, right? That's with most of the case whereby the voltmeter resistance is very small, ammeter resistance is small, but voltmeter resistance is very high. So again, there's a mistake with this line here, so please ignore it. Now A1, determine the potential difference across the 2 ohm resistor. A lot of you will just take 12 volts over here, divide by 2, okay, divide by 2, right? A lot of you will actually do that, and this is a most common mistake, right? Because this 12 volts is actually from here, 12 potential, here 0 volts, okay, meaning here is also 12 volts, here is also 0 volts. All right, so it means that this 12 volts potential difference of 12 volts is not just for the 2 ohm, right? It's for both the 2 ohm and 4 ohm, because in series the potential difference is the sum. So therefore I need to add up this resistor and make it into 6 ohm resistor. So now with this 6 ohm resistor, okay, I can say that it is 12 volts of potential difference across it. And with that, I can actually find, using V equals IR, the current flowing through. So I have 12, I is unknown, R is 6, so my I is actually 2 ampere. So if it's 2 ampere, right, that means over here, in this branch, I'm going to have 2 ampere of current flowing through. So the current flowing through the 2 ohm is 2 ampere, therefore the voltage or potential difference across it will be 4 volts. And I will also have the same current flowing through the same branch, because in series the current is the same. So I'm going to have 2 ampere passing through the 4 ohm as well. So the potential difference, V equals IR, will be equals to 8 volts. And when I have 4 volts plus 8 volts, it will be equal to the 12 volts. Okay, so the potential difference across the 2 ohm resistor will be 4 volts. Now state the potential difference across the 3 ohm resistor. Okay, so we'll make use of this. The potential here is 12 volts, the potential here is 0 volts. That means over here is also 12, here will also be 0. Okay, so therefore the potential difference across the 3 ohm will be 12 volts, because it is parallel to this 6 ohm resistor, and they are we have a potential difference of 12 and 0, so it will be 12 volts. Now calculate the effective resistance of the 2 and 4 ohm connected in series, so will be 6 ohm. We have done that calculation. The 3 ohm and 6 ohm, so because they are in parallel, so I use the 1 over REFF equals to 1 over 3 plus 1 over 6. Please don't forget to flip your answers. So in the end, your REFF is equal to 2 ohm. Okay, now calculate the reading on the ammeter. So this part actually helps with this, because the ammeter is found together with the 6 ohm and 3 ohm. So if I may, I would like to redraw the circuit. So this is my 2 ohm. This 2 ohm actually came from the 6 ohm and 3 ohm in parallel, and my ammeter is here, not affected by it. And I also have a, let's say, 6 ohm in parallel. Okay, so this is 6 ohm in series. Now this 6 ohm is parallel to the 2 ohm, and because these 2 branches are parallel, that means I have a potential difference of 12 volts across the 6 ohm. I also have a potential difference of 12 volts across the 2 ohm. Therefore, using V equals to IR, the V is 12, the current is unknown. What I need to find, the resistance is 2. Therefore, my current is 6 ampere. Okay, without further calculation, state what happens, if any, to the ammeter reading if a thick piece of wire is connected in parallel to the 2 ohm resistor. Okay, that means I have it's getting messy. Now I have a thick piece of wire. So with this wire, it will actually mean that there is a short circuit. Okay, there's a short circuit, but they are actually asking for the ammeter reading. Okay, so with this short circuit, it means that this is no longer in use because the current will prefer to flow through this short circuit wire. Yes, because there's no resistance. So this 2 ohm is actually effectively gone. However, because of how they are connected, right, the ammeter branch is in parallel to this lower branch here. Okay, so even though something has happened to the lower branch, but because they are connected in parallel, the potential difference is still 12 volts, right? So if it's 12 volts and nothing was done to the resistors over here, the current will still be the same. Okay, so ammeter reading will be the same. And what if the thick piece of wire is in D part 1, that means it still stays, and the 3 ohm resistors is removed. Okay, so maybe I do a quick drawing over here. Okay, 6 ohm, and my 3 ohm is actually removed. Okay, and I have my ammeter here. Then over here I have the short circuit piece of wire, because they said that, right? My 4 ohm is here. Okay, so now will there be a difference in the current through the ammeter? There will be, because now it's still 12 volts, right? But just now there was another resistor here that causes a difference in the resistance, but now it is just 6 ohm. So I have now 12 volts across this 6 ohm, and this current is going to flow through this 6 ohm and into the ammeter. So the current V equals to IR will be 12 equals to I and 6. So my current will now be 2 ampere. Okay, so the answers are here. I think it's the same. So the ammeter reading will actually decrease. Just now it was 6 ampere, right? So it has decreased. Okay, so please check your answer. Okay, question 7. Following shows a circuit containing a battery, 3 resistors. They all have different resistors. 2 ohm and 6 ohm are in parallel. Then I have 1 ohm in series with that. Write down the equation for the effective resistance of 2 resistors of resistance R1 and R2 connected in parallel. So 1 over REFF. They use RP, right? So over 1 over R1 plus 1 over R2, and this is okay. Okay, use the equation in A part 1 to calculate effective resistance of the 2 resistors in parallel. So it's 2 and 6 will be 1.5 ohm. Okay, you can check your answer. You shouldn't be making any mistakes with this calculation. A voltmeter is used to measure potential difference across the resistors in parallel. So you need to recognize that it is in parallel. So the answer is this, right? On the circuit above, draw the voltmeter. We have done that. Ammeter reads 1.6 ampere. Calculate the reading on the voltmeter. So this ammeter actually has a reading of 1.6, which means the current flowing through the 1 ohm is 1.6. Yes. Do we know the EMF? We don't know. Okay, but they want us to calculate the voltmeter, the reading on the voltmeter. All right, we can do that. Okay, so let me draw the circuit larger, 2 ohm. Then I have a 6 ohm here. Okay, and I have 1.6 ampere. I don't need the ammeter. My 1 ohm is here. All right, so this 1.6 ampere actually passes through this 1 ohm. And this 1.6 ampere was from the sum of these 2 current. Yes, was from the sum of these 2 current. So maybe I will convert this 2 resistors in parallel. Remember, they asked us to calculate the effective resistance into 1.5 ohm. So 1 ohm, and I still have this 1.6 ampere. Okay, so this 1.6 ampere actually passes through this 1.5 ohm. So I can use V equals IR equals to 1.6 multiplied by 1.5. Then I will get 2.4 volts. Okay. Now state what happens to the ammeter reading if the 1 ohm is replaced by a 3 ohm. So now if this becomes 3 ohm, the effective resistance of the whole circuit will increase, right? So instead of 1.5 and 1, it will now be 1.5 and 3 ohm in series. So the total effective resistance will now be 4.5 ohm. Okay, so with this, I didn't make any changes to the battery, so the V will be the same, the EMF will be the same. Divided by a larger resistance, I will have a lower current. Therefore, the ammeter reading will decrease. Okay, so this question is quite easy. Expect this kind of questions to come up, right? Okay, the circuit shown below uses the 12-volt battery. This is question 8. Switch S is open. State the value of the reading on the ammeter. Because there's no current flowing, so it will be 0 ampere. So what is the value of the potential difference across S? So across S will be here and here, right? So here will be 12, here will be 0. So I will have a potential difference of 12 volts. Okay, so this one you may need to take note because we are doing with potential, yeah, because there's no current flowing. So here will be 12 volts, here will be 0 volts. Okay, then now switch S is now closed. Okay, so let us redraw this circuit very quickly. 16 ohm, then I have 8 ohm here, and this is 12 volts. Calculate the current. Okay, therefore I need to add this into 24 ohm. Yes, so that I can calculate the current. 12 divided by 24, therefore the current is 0.5 ampere. Calculate the potential difference across the 8 ohm. Very simple. This 0.5 ampere flows through this 8 ohm resistor. V equals to IR equals to 0.5 multiplied by 8. So I will get 4 volts. Okay, how about the voltage across this 16 ohm? 0.5 ampere also flows through this 16 ohm, right? So V equals IR again. My I is 0.5, my R is 16. My R is 16, so I will get 8 volts. So you see 8 volts plus my 4 volts will actually be equal to 12 volts, right? In series, the potential difference is sum. Now, the two resistors are now connected in parallel. Calculate the new reading on the ammeter when switch S is closed. Okay, so maybe I need to redraw this circuit. Okay, always redraw circuit. It will help you to see things much clearer. So 16 ohm here, and let's say I have the ammeter here. I have 12 volts. Okay, so 8 ohm and 16 ohm. What is the effective resistance? It is 5.33 ohm. Okay, I just use this. So then I will redraw this as 5.33 ohm. Okay, I have my 12 volts. Then I can calculate the current by using V equals to IR. Okay, if not, I can also use 12 volts here for this 8 ohm and 12 volts here for this 16 ohm. Find their individual current. Let me show you. V equals to IR. V is 12. My I is unknown. R is 8. I have V equals to IR for the bottom branch. 12 equals to I, then 16. So I will be a certain value. Let's call it I2. I1 will be a certain value. And because they are in parallel, so the current will be sum up. And it should be equal to 2.25 ampere. You can try and check. Okay, actually they also have the working over here. Okay, question 9. Is it in your... Okay, this one may be a bit tough. Let me see if it's advanced or... Okay, so this is advanced, so you may not have it. Okay, so we'll skip this, but if you want to know, you can check the answers. Okay, question 10 is also advanced, so you may not have it. Okay, I may be wrong. Please let me know. Okay, so this concludes the DC circuit. Okay, so actually, I think if you want, you can try question 9 and 10. Okay, you just take a screenshot, or you can ask me. or you look at the uploaded answers, and then let me know if you are interested to try. Okay, thank you.